Moving on to question 4 now, we have a very brief question here, and we're dealing with iteration. So, part A, we're given this curve with equation y equals 2 ln 8 minus x, and it meets with the line y equals x at a single point, x equals alpha. And we have to show that alpha here lies between 3 and 4. So they give you this little bit of a graph here, just showing you what's actually going on. So we've got the curve here, 2 ln 8 minus x, and y equals x, and the mean at this point here, which must be alpha. And we're given the iteration formula below, and then for the second part it's just asking, will this, can it be used to find an approximation? But let's tackle part A first, and then we'll move on to part B. So part A, we just have to show that alpha lies between 3 and 4. So very common question this on iteration questions. What you have to do is look for a change in sign and show that this is continuous over a given interval. So what we're going to do is consider f of 3 and then f of 4. So f of 3, well, that's going to be 2 ln 8 minus 3. But don't forget, guys, this also meets the line at y equals x. So we have to subtract this extra point off here. So this is going to be 2 ln 8 minus 3 minus 3, like that. We're considering this at f of 3. So that's 2 ln 5 minus 3. And what does that give us? So that gives us 0.22. 0.22. Now let's consider f of 4. So we should hope that this value comes out as negative f of 4. If it doesn't, something's gone wrong with one of our calculations, but it should do. F of 4, so this is going to be 2 ln 8 minus 4 minus 4 on the end, like that. So that's the same as 2 ln 4 minus 4, which is going to be equal to minus 1.23. Alright, perfect. So therefore, we know alpha does lie in this interval. So you've just got to finish this off now, guys, with one statement. All you've got to say is therefore change of sign, change of sign, change of sign, and we have to say that it's continuous over the interval 3, 4. So I'm just going to put cont for continuous between 3 and 4. So you have to make sure you say continuous as well, guys. It's part of the new spec. They do want to see that. So it's continuous between 3 and 4. And that gets you both marks for that. So that's part A done. Now for part B, it asks, does this iteration formula given, will it approximate to find alpha the root? So it kind of looks like there's not much you can actually do with this, and this is where part of the new spec comes in. This is one of the cobweb diagram questions. So to do the cobweb diagrams, look at the first value that you've been given. So x1 is equal to 4. So if we start at 4 here, what we're going to do is we're going to go straight up, and wherever this line then from x1 equals 4 intersects with one of the curves or the line, we move across then. So to demonstrate what it's going to look like is if we start at x1 equals 4, it's going to go straight up. So this should be perfectly straight. I'm doing this freehand, so it's not going to be brill, but like that. So we've now intersected the curve here, like that. So now what we do is we go to the left to meet another curve or line. So if we go to the left here from this point, and then once we get to a point we stop again here. So we've met the line now. Now again, we're going to go up. We're going to go in this cobweb sort of shape. So we go up until we meet a curve. We've met the curve, let's go across again. We've met the line, we stop there. Again, keep going, we're going to hit the curve next. Perfect, we've hit the curve. Now we're going to go across again, we'll hit the line. And this is what the cobweb diagram does. It builds this like this little spiral. So if it does approximate, what you should get is that using the curve and the line, it will curve inwards like this. If it doesn't, it's going to look different, it's going to curve sort of outwards. So therefore for part B, so if we just change this back to white. For part B, this will approximate. So yes, will approximate. Will approx. And the reason is because of the cobweb diagram. So that's how we did it up here. So we start at 4, go up till you meet the curve, and then you just bounce between the line and the curve, the line and the curve, and keep going. Now this could keep going on forever until it does converge to the root, or you can say it will converge like that. And that's all there is for part B, and that's question 4 done. So quite a quick question, hopefully quite nice as well.